Okay, so what are we at today? Right, I'm back in the middle of Ireland again. We are looking at our first case study for fold mountains. So we're finished with types of folding, how fold mountains occur. We looked at the distribution of fold mountains in Ireland, and now what you need to do is look at the impact of folding on the landscape. So if you think about it, the impact of folding is basically the creation of fold mountains. So that's how folding impacts the landscape. It compresses it and it makes it into ridges and valleys. The ridges being the top bits and the valleys being the bottom bits. So another word for a ridge could be an anticline, another word for a valley could be a syncline. So we have to look at the impact of folding in Ireland, and our case study for that is going to be Munster, Ridge and Valley. And I have mentioned this several times before. It's an example of how folding has affected the landscape in Ireland. And there are other examples. We saw the example of Caledonian folds in Dublin Wicklow. But the thing about Munster, Ridge and Valley is it's affected a large part of the landscape. And that's why it's more effective in terms of a case study. So it's called Munster, Ridge and Valley because it's in the province of Munster and it's made up of loads of ridges and valleys. In order to understand the impact of folding on the landscape, we have to examine what the landscape in Munster looked like before folding and then after folding. So that's why we start way back before. So this is Armorican, which means it began 250 million years ago. But when we're talking about Munster, Ridge and Valley, we'll be talking about what was the landscape like before 250 million years ago and what is it like after 250 million years. And it's only then that you can see the impact that folding has had on the landscape. Okie dokie. Right, so here is an image of Munster, Ridge and Valley, just to give you the ideas. You can see the ridge running across here. You've got valleys in between some of the ridges, and then you've got a valley back here. And actually this is, yeah, I think it is, this is Carrauntoohil up here. So this is Ireland's highest mountain. I have some nice photos lined up with that. And when you walk, you have to go all the way here and you climb this part here, and this is called a Devil's Ladder because it's very steep, and when it's wet you're basically just climbing up a waterfall, and then you go up there, and when you're hiking back you come back down this way. But there are fab views at the top when it's not foggy. Alright, so why am I showing you this picture? Well, basically this is the before picture of the landscape. So about 350 million years ago, Ireland was located much closer to the equator. And at this time, this is what Munster would have looked like. So because we were closer to the equator, we would have had a hot desert type of climate. And there was a huge amount of this type of sediment. This then got converted into sandstone. So 350 million years ago, we would have been located closer to the equator. Munster would have had a hot desert climate, and at this point a lot of sandstone was formed. Alright, and sandstone is just formed when sediments are laid down in layers and compressed. Then about 300, so this is known as the Devonian period in geology. Devonian period. Okay. Then, approximately 30 million years after that, we go into the Carboniferous period. I know this is a bit confusing. So these are geological periods, Carboniferous period, and these are in your notes, I think, or maybe they're not. Anyway, no harm knowing a bit of geology. So we're talking about time periods. We've already talked about one type of time period, which are the periods of orogeny. So they're the periods of mountain building, and they are Caledonian, Armorican and Alpine. These periods that I'm talking about now are geological periods. I might just be confusing everybody, but anyway. So 350 million years ago, and then we zip forward, sandstone was formed, and then 320 million years ago, this is where Munster is at this time. So as we move further north, away from the equator, basically most of Munster was submerged beneath this shallow sea, a warm, shallow Carboniferous sea. And what happened here was, because there was loads of sea creatures that were dying and building up, that limestone formed. So the sandstone formed first during the Devonian period, 350 million years ago, and then the limestone formed next during the Carboniferous period. So basically the limestone formed on top of the sandstone. And these were all laid down in flat layers. Okay, so no folding would have occurred. So we would have had sandstone, because that was formed first, layers of sandstone, and then on top of that we would have had layers of limestone. So that's what the geology of Munster would have appeared prior or before folding. Okay, then 250 million years ago, which is the start of the American mountain fold building period, the two plates, the Eurasian and the African plate, were colliding. Okay, and this caused the layers of sandstone and limestone to fold upwards. Now, the main collision zone was way down here, and Ireland was to the north of the collision zone. So that's why only the southern part of Ireland was affected by it. Right, let me try explain that a little bit better. Where is me thingamajig here? My pen. Right, so can I get a blank screen up? Okay, come on. So what I'm trying to explain here is the collision zone. So if this is the main collision zone, okay, and we have the African plate down here, and we have the Eurasian plate here. Ireland was located just to the north of the collision zone. Right? Beautiful representation of Ireland. So that means that not the whole island was affected by it. In fact, it's probably a little bit further. So only the Munster part was mostly affected by it. And this is what this is showing you here. So do you see the way it says areas of intense folding and mountain building? Because this was the area that was closest to the collision zone, whereas there was less pressure up here, so outside of Munster it wasn't really affected. And then the other thing to note was that the mountains have an east-west trend, and that basically means that their peaks are running in an east-west direction. We talked about that the other time. So during folding, the south of Ireland, i.e. the province of Munster, was compressed, and the layers of sandstone and the layers of limestone were folded upwards. Okay, so this is the before picture. This is like, you know, if Munster Ridge and Valley had an Instagram and they put up, you know, the kind of those before and after pictures when people go on these mad bodybuilding sessions. Well, this would be what Munster Ridge and Valley would be doing. So this is before folding at about 350 million years ago. So we have the layer of sandstone and we have layers of limestone above that. Okay, now I need you to pay attention here because this is important. This is what happened during folding, approximately 250 to 300 million years ago. The layers of sandstone and the layers of limestone were folded because of compressional forces at a convergent plate boundary. Now, limestone is a very soft rock that's got joints and that's got cracks in it, and we'll be talking more about that when we discuss limestone. Because it's a soft rock, when it was folded upwards, the edges, the bits on top of the fold started to crack. So if you think about a Mars bar, and if you were to gently fold a Mars bar, what would happen to the chocolate on the top? It would start to develop cracks in it. And this is what happened with the limestone when this was folded up. They're not faults, they're just cracks in the rock. Okay? Now, this then allowed water to get into the rocks. So it rains and water gets in. And if you cast your memory back to junior cycle geography, if water gets into these cracks, then carbonation happens. Do you remember that it's a type of weathering? So weathering means it gets worn away. Freeze-thaw action would also happen. Okay, and if you don't remember that, don't worry about it too much. But basically, when it rains, water would get into all of these cracks and it would start to weather the limestone. That means wear it away. And because limestone is a soft rock, it gets eroded and weathered really, really quickly. All right. So when the limestone was uplifted into anticlines, it developed cracks. These cracks meant that it was vulnerable to weathering and erosion, and this then removed a lot of the limestone from the peaks. So because the limestone was removed because of weathering, then the sandstone beneath kind of peeks through. Does that make sense? So because the limestone was eroded away from the anticlines, it exposed the sandstone beneath it. So if we go back to the middle picture here, right, for a sec, if all of this gets weathered away, okay, so if we remove all of this from the top, and that's all the limestone, then what's going to be on top is the sandstone. All right, all of these layers, these peaks of sandstone are now going to be on top, and that's what's happened down here. But sandstone is a much more resistant rock than limestone, so this doesn't get worn away as fast as the limestone gets worn away, so this stays on top. And this is why today in the Munster region, in the mountains, that we see sandstone peaks. So we see these red peaks in Munster Ridge and Valley, and this is called Old Red Sandstone. So somebody with a great imagination came up with this name. It's old. It was formed Old Red Sandstone. Old because it's old. It's 350 million years old. It's red because it's got iron oxides in it, and it's sandstone. So the sandstone in that region there is known as Old Red Sandstone. Now, if you notice the valleys or the synclines, they still have limestone in them, because that was protected. It wasn't on the anticlines, and it didn't get cracked. So a lot of the valleys in Munster Ridge and Valley have rivers running through them, and they are made of limestone valleys. All right. So the impact of folding on Munster was that it folded the layers of sandstone and limestone. When the limestone got folded, which I probably shouldn't have scribbled all over that, it cracked. It allowed water to weather it away really quickly. This then exposed the sandstone peaks beneath it, and now in the region we've got Old Red Sandstone on the peaks, and we've got limestone in the valleys. Okay, so this is like a cross section through Munster Ridge and Valley. If you were to cut down into the middle of it, this is what you'd see. So the anticlines are made of sandstone because all of the limestone has been removed. The synclines, or the valleys, are made of limestone. Okay, and basically you need to be able to explain why, and that diagram's in your notes on page 13. And these are just some images from the air. It really is a beautiful part of the world. So you can see here we're in a syncline, and there will be some limestone down here, and these peaks will be made of sandstone. And up here, these are the Comer Mountains, which are a bit further east, but you can really see the sandstone coming through there on the peaks. Oh, and here is Carrauntoohil. So here's my these are my photos from last summer, I think. This is Ireland's highest peak, and this is the way up there and all the way up there. And these are the views from the top. Absolutely amazing. So you're looking down on these two lakes that were formed by glaciers, and you can see these peaks up here as well. And here is me and Sloth. Sloth wasn't happy with this hike because he just prefers to hang out in his tree and not do an awful lot all day, so he was pretty knackered. Huge amount of fog at the top there, so we actually couldn't see anything. But it's mad to think, and this is what was going through my head at the time, that at that point in time we were the highest people, well, person and animal, in Ireland. Isn't that mad? We were the highest in Ireland for those few minutes, and then my kids get crashed, and they were the highest children in Ireland, so they were delighted with that. But yeah, go climb Carrauntoohil, it's really worth it. Alright, and this is in the valleys, and these are just to show you limestone cliffs, and that's the Blackwater Valley in Cork. Okay, so this is the diagram that you are expected to draw, but I'm going to put up a version that I did of it, so that needs to go on page 14 of your notes, where it says Munster Ridge and Valley diagram, and I will post another picture of it. And that is all for today. What I want you to do is I want you to read through page 15. Actually, I'm going to read through that with you because this is a really important case study. Then you're going to do the exercises on page 17 and 18 of your notes, and I'll post a picture of those afterwards. You don't need to put them into whatchamacallit. Hang on, I'll get myself back up. Okay, so you don't need to put them into teams, or I won't do an assignment for it. I just want you to do them and trust that you do them, and then I will post the correct answers, and you can correct your own work yourselves. All right, so that's all of that is very, very doable within your 40-minute class this morning. Well, if I would stop talking and this video would be shorter, then yeah, I'll get rid of myself so you can go and do everything that I asked you to do. And your diagram, really important you get the diagram in on page. What page am I on here now? Sorry. Oh, hang on. I might be giving you the wrong page numbers because I was looking at an old booklet. Ignore any of the page numbers I said. I'll go and type them up properly. Do I need to read through page 13? Pause and just look. No, I don't feel like I need to read through it. But you need to read through it. Okay. No. Oh, I'm giving you the wrong page numbers again, but I'm not re-recording this. Okay, goodbye.